Let's revisit this problem, but this time, instead of using formulas to get our test statistic and p-value, I'll show you how to use your graphing calculator. So let's recall the claim that we're trying to test, and that's the claim that the proportion of male BSN students is less than 15%. So let's go ahead and write that in symbolic form. That's p is less than 0.15. Because that doesn't have the equal sign, that automatically becomes the alternative hypothesis in step one. So I'm going to go ahead and write that down and keep track that this is also the original claim, the alternative hypothesis. So that means the null hypothesis is going to be P equals 0.15. And then before I actually take a look at steps 2 through 4, let me go ahead and make a sketch on the side of my paper here of the bell-shaped curve so I can approximate with the normal distribution. At the center of this distribution is your p-naught value, this p-naught value. You'll need it for the graphing calculator function, so that's 0.15. And then because the alternative hypothesis contains that less than sign in the alternative hypothesis, this tells me that I have a one-tail left-tail test. So that means that my critical region and the area of the significant, or the critical region is on the left, and it has an area of 0.05, which is also our significance level. So I'm going to skip down here to step 3, and let's go ahead and calculate the negative critical value, so that negative z-score. So I'm looking at negative z sub 0.05 with an area of 0.05 on the left. And again, the reason why I'm looking for a negative critical value is because the test is a left-tail test. Okay, so what is the z-score that separates the critical region on the left? And I don't know why I wrote critical left here. I think I was talking and writing at the same time. So this is your critical region. All right, now what were we doing? Okay, we're calculating the critical value. So let's go to our calculator, and you're going to go to your distributions by clicking on second bars. We're going to choose inverse norm here, which is option 3. Type in the area to the left, which is 0.05. And then we're on the standard normal distribution, so use 0 and 1 for sigma, for mu and sigma, and then go down and press enter, and you'll see that that gives us a critical value of negative 1.64, which is the z-score that separates that red shaded region on the left. Okay, now how do we get our test statistic and our p-value without having to use formulas? And the answer is we're going to use a function called 1 proportion z-test. Now, you want to make sure that you understand how to use and when to use certain tests. So to get to the 1 prop z test, you're going to go to stat, tab over to test, and you'll see that by the end of the semester, you will have learned how to use most of these tests that you see on this list. And it might be difficult for you to differentiate between the tests. So students are always like, oh gosh, there's so many different tests. I don't know when to use which test. And my answer to that is just use your common sense, okay? We're testing a claim about a proportion, so you're going to choose a test that has the word prop in it, which stands for proportion. We have only one sample that we're looking at. So we're looking at a sample of 350 BSN students where 42 of them are male. So that is what the 1 stands for. We only have one sample, okay? Z is because our test statistic is a z-score and we're approximating with the normal distribution. And then test means you're doing a hypothesis test. So if you're trying to do all of those things, you have one sample, you're looking at the normal distribution, you're testing a claim about a proportion, and you're trying to do a hypothesis test, then the test that you're going to choose is 1 prop z test. So let's go ahead and choose that option. And it's going to ask you to put in some information. So the first thing that you're going to type in is your p-naught value, which is 0.15. Then you're going to type in your x value and your n value, because x over n is what's going to give you p hat. So p hat is x over n. Okay, and in this particular problem, that's 42 over 350, or 0.12. So that's your sample proportion. That's called your sample proportion. So that's what a p hat value is. Okay, let's go on and talk about this 1, 2, 3, this fourth line. This fourth line should match up with your alternative hypothesis. So go to the alternative hypothesis, all right, match that up. It's saying the proportion P should be less than P naught, where P naught is 0.15. So P less than P naught, or less than 0.15. That means you're going to choose the second option. So please make sure that you press enter to actually highlight that option. And then now let's press calculate. And the one prop Z test gives you all of the results of the test in one screen. So the first thing that it tells you is your alternative hypothesis. So always take like 5 seconds to check to make sure that this matches up, because a common mistake that students make is they don't match up what they write in step 1 with what they mean to put in the calculator. Our Z-score, or our test statistic, is that Z-score. So let's write that down. That Z-score is negative 1.57. And our p-value is the third line here. So I'm going to write that down as step 4. That's 0.058. So take that out to 3 decimal places. Now let's talk about what the test statistic and p-value looks like on this bell-shaped curve. So I'll use different colors here. I'm going to mark the test statistic in green, and then I'm going to shade in the p-value also in green. So notice that our test statistic is negative 1.57, so it's right here. Right, negative 1.57, and I'm going to shade in the area that corresponds to the area to the left of that test statistic. And so the area shaded in green, that is our p-value, and that shaded area is 0.058. So notice that in the picture we can see here that our p-value is greater than our significance level. So we've got a p-value. It's not that much bigger, but it's still bigger. 0.58 or 0.058 is bigger than 0.05. So this is going to help us make a decision about the null hypothesis. I'll write it here, step 5, decision, okay, about your null hypothesis. So if you're using the critical value method, right, notice that our, I'm going to use purple here, that our critical value does not fall in the critical region. So that purple marking is not in the red region. So the conclusion that we would make is we would fail to reject the null hypothesis. Same thing if you're using the p-value method, because the green shaded region, which is our p-value, is greater than our significance level, we would also fail to reject the null hypothesis. Now let's state our final conclusion and address the original claim. So in step 5, we fail to reject. So fail to reject, right, our H0 claim. So what does that mean? This means that there is not sufficient evidence to support the claim that less than 15% of BSN students are male. Okay. All right. So that's how you would use your graphing calculator.